Oh, you were at Mboned. You're in Bangkok, Thailand, and it's November 3rd. Everyone okay? 2018. All right, good. For you time travelers that may have visited here, let's see. I have the right buttons here. I'm warning you up front. This is the first time doing the whole thing from Chromebook. I'm going to make mistakes, but it appears so far to be moderately functional. Note well. Well noted, everyone. Can I have a volunteer to take minutes? Do we have anyone on Meet Echo? We have someone on Meet Echo. We have someone operate that. We got a Meet Echo. All right. How about minutes? Everyone's looking down. I know I was busy though. I know I'm not even gonna look at you. I was busy. I was preparing for this. But I think next time we'll do a reciprocal. I'm due. All right. Make it much easier on everybody. Anyone, please.
You looking at Mike?
No, I can't ask Mike because I didn't help him out last session.
I think you here.
You're my best friend. Come on, we can't roll out without notes. It would take a minute. Everyone's got to do it at least once. It actually is a really good way to stay engaged and force you to learn people's names. It's not working. Jake's done it before. I know you've done it before for us.
Yeah, I did my last term.
I've ground stick. This is a great jump. Me Echo get you off the hook there. Mike's off the hook.
I'll do it.
Oh, see that? 2x. All right, I'm going to ask you a question. Who here has never done minutes before in a working group? Oh, you liars. All right. Thanks, Jake. And you got my email, so forward it when you got it. Here's the agenda. Anything missing? Anything we should be talking about? We're not talking about? Anyone want to pour a little out for? All right, we're cool. Excellent. I got the right button. I'll go to the next deck. And this is my friend Torlis. He's going to talk to us today. Hi, Torlis.
Sorry, that was trying to.
Oh, that's the wrong one. It is, no,
No, it's the right one.
I changed my agenda twice.
Okay, let me see. Does the button work? No, you have. Next slide, please.
What's that button doing?
No,
Doesn't work?
That thing doesn't seem to work.
Okay, so I'll be your,
Yeah.
just say boop.
Okay, so IETF 102, we had version 00 of the working group accepted version of the draft. Then Lenny took the initiative and did in -01 a really good textual cleanup, simplifying things, doing actual English, as opposed to what maybe I and other. Anyhow, it wasn't on data tracker so Henrik fixed that. So you can look up the diff between 00 and 01 now. I didn't put anything in there because of that diff, because there weren't really big, functional or block changes. So then I basically tried to add in -02 the elements that had come up through the discussion, especially with the enterprise customers that got confused with the meaning of this, even though we felt interdomain was very clear, and we're not talking about intradomain. But the main issue being that ASM is more than PIM sparse mode, and a little bit from people looking in the interdomain space, they think ASM is just like PIM sparse mode. So basically mentioning BIDR PIM was important here to say, that is an intradomain only solution. It does also do ASM, and it's basically not impacted by what we're saying here about interdomain ASM. Instead, it's actually, also what one of the latest slides says, one of the big reasons to not even start thinking now about deprecating ASM intradomain, because BIDR PIM there really is enabling applications you couldn't otherwise do. Next slide. Okay, section 2, just cleaning up. So instead of called the whole section background, then basically has section 2.1, which is the multicast service model called ASM and SSM, little bit text improvements, no major changes there. Then in 2.2, which is the routing protocols, added section about BIDR PIM, right? What I said, key reason not to deprecate intradomain ASM, scales app intradomain that we can't equally do with SSM, but no interdomain. 2.3, SSM routing protocols. When rereading the RFCs, one of the interesting tidbits is that SSM is actually not agnostic of the routing protocol, but it really mandates PIM SSM, which, makes the solution scope a lot more constrained for us, which, just just a
This
note
is
here.
lack of foresight. I mean, it's all we had at the time.
It was all we had at the time, but it also means if somebody comes up with a cool new protocol that does SSM, it wouldn't be covered by that one. So it's just more a curiosity gig. Next slide. Okay, so then 3.2 restructured into the three key area of SSM benefits that, the way I've always liked to talk about them, to explain it's not only the operational stuff, even though this work, I think, was primarily driven by the service provider's operational issues. So the reduced network operation complexity, and just added a note there that this is just about the interdomain PIM sparse mode, not about BIDR PIM. So then 3.22, there is no network-wide IP multicast group address management need in SSM. That's a humongous thing for anybody wanting to deploy applications. And I also added the references to these wonderful 3 RFCs that were done in the 90s to manage ASM multicast group addresses. So the IETF worked on 500 pages of documents. I forgot the name of them. One is MASC and MDISC and something, and they were also happy and nothing happened. So there is, the IETF tried everything to manage ASM group addresses and it doesn't work, right? So, I mean, that I think was not only historically interesting, but also just to level up a little bit the severity of the problem. Then 3.2.3, that's the intrinsic source control security. So I added more explanation on how SSM traffic, how SSM itself protects from unwanted sources because it discards the traffic on the first hop. If you don't have SSM state there, it doesn't get anywhere down into the network, but is discarded on the first hop router. So that's a really cool security properties, right? I mean, why do we have all these firewalls in the network in unicast? Because unicast doesn't have that property. You send traffic and you can get all the way through the world before somebody discovers, I don't want this guy to get to the destination. So that I think is also cool to highlight to people who are not really entrenched into the SSM solution. So then on the section 4, which is about what things should we still do, what are we missing? And so I think the section 4.4 that I added was really, we need this guidance for application developers. When is an application right for SSM, ASM, and then I made the category service discovery because, and I think Mr. Registry supporter Stick can talk to that a lot more. It's on the registry. What is it called, right? The IPv4 address space there, and all these requests for another ASM group address, and they're all because application number 1450 from some enterprise or software vendor wants to get yet another ASM group address just to basically send out a discovery message to find its server, right? And that's why we have ASM in many networks, and that's so ridiculous. So I think really the application development guidance should really distinguish between these three things, right? When do you need ASM? That's typically these BIDR PIM application. Otherwise, it's SSM. And if you ever want to do something like service discovery, uses this service discovery mechanism. There is DNS SD as an architecture, and there are now more and more transports using them. And nobody in his right mind is trying to use ASM as a transport for, let's say, MDNS. So that's basically the missing stuff, new section that we should have follow-up work on. So the 4.8, not precluding intradomain ASM, added the notion about BIDR PIM deployments. Summary, this document makes no statement, rather encourages BIDR PIM intradomain. And then 4.9, I was trying to be more precise about the simplicity of evolving existing PIM SM deployments for SSM, right? And that basically is something that almost works out of the box. In some vendors, you need to globally enable SSM. So I think Cisco required that. Juniper has it on by default. The only interesting thing in that text may still need improvements is that we had over the time all these asks whether we should also do SSM applications over an ASM address range. And that can work. You can make it work. You can also shoot yourself with a long gun into your mouth or something like that. So I may, want to say that we should rather make only recommendations of do SSM in the SSM range and not try to make it work in the ASM address range. But again, read that text, and maybe that's still something we want to finalize on what we all agree on.
Jake Highland, GLAP, I think, also says it's allowed.
So say that again. GLOP does what you said?
GLAP says it's allowed, I believe. That's like up to the owner to decide.
But that's not for SSM. That's just for
that was my read on it. up to the owner to decide how it's,
Oh, I see what you're saying. You own this prefix now. Do
Yeah.
what you want with it.
right.
All right. But
Right.
that, as long as it's within your network.
Yeah,
Right. You can't
You own the
guarantee,
prefix, it's globally, you can decide
Yeah.
which way it's supposed to be.
but you can't guarantee receivers on the other end not connect to your physical network and treat that address as an SSM address.
Receivers
They may-
going to be receivers.
Yeah. What's that?
Receivers are going to be receivers. Yeah, they do all kinds of stuff.
Stig, but it's your address though, so no one else should be using that address for other purposes.
no, the
Every
global-
router in the hop uses that address.
But you should be able to control how your routers or
Yeah,
No, 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 wait a
But
second.
But if
Glob is
you use your
global.
network, it's no longer your router.
You're allocating addresses to it, but you
Yeah.
still would need to figure out how the bloody whole internet for a glob address uses the right forwarding mode, like either PIM sparse mode or PIM SSM. And there's a difference, right? So it's a tricky wicket, right? And the very simple solution is we're not recommending to use SSM in any ASM address range, including glob, right? And basically there may need to be some text for v4 to say you should be able to have, private RFC 19 address, 1918 type of SSM addressing space if you have private deployments. I think most vendors do support that config option. V6, we don't have an issue, right? Because we have enough, scoped address spaces that, you do, what is it, our scope, organizational or so for a service provider and all its customers, right? So those,
yeah, for V6 you have a simple way of saying it's SSM regardless of scope, kind of.
exactly. But I'm saying that if you want to have a private deployment, your IPTV traffic for all your customers, there might need to be a follow-up recommendation, use scope 5 or something like
Yeah,
that. I
just
think
use
there
a
was even
lower
in some
scope.
documents, if I
Yeah,
remember
yeah.
correctly.
But yeah, this will be for, I mean, I think some people use 239 something for SSM
Yeah.
just because it's,
239, 232 is what I
organizations.
recommended
Yeah.
for a decade, right? So anyhow, addressing, that's basically for the evolution part, I think something we still need to work out the full text that we want to have there. Next slide. So then future ASM work. So what I'm saying there is fairly strong. So this document does not believe that any ASM solution, even with such future work, there was some paragraph about possible future things to make ASM better, can ever provide the same intrinsic security and network and address management simplicity as SSM. See that section 3.2. Instead, this document believes that future work for general purpose interdomain IP multicast is better spent on the SSM items listed in section 4, which is where we had these things. Yep, that's it. Hope that
Questions?
makes it better.
Yes, it's evolving. Thank you, Torres. When did you post the latest ref?
That was posted 2 weeks ago.
Was it 2 weeks ago? Okay,
Before the
all right. How close do you think this is for last call, personally?
I think that addressing stuff would be, in my opinion, technically the open thing where we should maybe open up a discuss item on the mailing list, what we all think we should
Okay,
write there. And
so usually I'll kick off discussion with the last call. It kind of sits in people's queue, not paying attention, so the last call comes up and they jump on it. So we can light a fire to get a discussion going like that. But the light one's under your tail then too to respond. So
let's give it 2 weeks for the authors, so
Okay.
that we all agree, and then we'll ask you for.
Great. So-
strategy as well.
All right.
That's always with people.
yeah, right. I'll fire it off to the authors list first, make sure everyone's on the same page, and then we jump. All right. Thank you. Bye, Torles. Thanks for playing. That went away. Multicast trace route. Am I on the X? I'm not even paying attention. I'm sorry. Torres is probably like a chopped off camera half the time. Right?
Oh, does this work?
You can try. We're not getting success. Look at that. Amazing.
Okay, so I think in last IETF we had mtrace as a RFC in last 3-4 months, I guess. And after that, we wanted to work on mtrace for MVPN. And that's when I reached out to Greg and Lenny to have a slot just for discussion. And they bring up a point that there was already a draft long back, and it was kind of expired. So we wanted to revive that and have just a quick discussion here. So right now, this draft, I think it was presented in IETF 90, and after that, there were some comments, and comments were not addressed, and draft was expired. And since MTrace V2 is now RFC, we are revisiting here. So right now, this draft, there is no change from whatever it was during IETF 90. We have just submitted the latest version, and we are going to address all the comments which were received earlier, and we are planning to have some discussion in mailing list, or if there are any suggestion in the room that what all things we can include. So just a quick recap, what does MTrace V2 does? So you have a query going, and so query will go hop by hop, and the response will be unicast to the whoever has originated the query. So here R1 is doing query for source, and it goes hop by hop till R6, and R6 replies it.
I think you usually hit the right button, the right arrow. There we go. You just, I do left, right, I can do full pages with that one.
Oh, it's okay then.
Yeah.
Okay. So this was the MTrace V2, which became RFC. And what is missing in the MTrace V2 is so basically we have provided a way how it is going to work in the PIM domain or native multicast domain, but the document clearly says that it doesn't cover how exactly it is going to work in the MVPN. And that too, when MVPN has different types of tunneling mechanism, different types of encapsulation, how we are going to do, what kind of reports we should be sending back to querier, and those kind of open questions are the one which we are going to cover in this draft. So MTrace for MVPN, the way we are planning to do here, we have PE1 and PE2, they are MVPN peers. And when querier is sending query, now it goes over a core, and okay, so, and we are getting the response back to the querier. But here Stig and I, we were having a couple of offline discussion that what all things we can do. Do we want to print, do we want to have information about each hop in the core router, or we want to have what kind of tunneling is being used, what is the starting of the tunnel, end of the tunnel. So those are some of the points which we wanted to get inputs from the working group so that it can be incorporated in future document. And in case of error condition, actually the last hop itself can directly respond to the querier that there is some issue in getting the query packet from the tunnel. And by the way, most of the presentation, I took it from the last presentation itself, because we have not made any changes. So I just wanted to have kind of quick discussion. Thank you. Any question, any suggestion?
This is Stig. I'm wondering if people think this is useful, and also if we should consider other types of tunneling, not just MVPN, but anytime you have a multicast tunnel, it's kind of interesting to know what are the routers you actually tunnel through and where any issues happen, and maybe what type of tunnel you are traversing and so on.
Stig, Greg as chair, just kind of following up on the question. So this assumes stateful hop-by-hop tunnels. It's the only way you know what the actual topology is with this, because effectively beer is a tunnel as well, but it's this multi-point mesh. There's no stateful hop-by-hop.
Right. I was thinking a little bit about how this could be done for beer, and yeah, I'm not sure if you can do it with beer. I mean,
Which you can extract the SPF tree from the IGP, but that's not the affirmation that the packet has taken that path. There could have been something else. As opposed to state, that's where it's going to follow.
Yeah.
So, I guess looking at the fib, the same thing. It's still state, right?
Yeah, so we may not be able to get the intermediate routers, but it could be useful to at least know that, okay, at this router, we are switching to a beer tunnel, whatever.
Yeah.
So if there's a failure, we can know, okay, it might be beer related.
Okay,
Thank
feedback. Thanks. Thank you.
It would be interesting to see AMT also. Yeah.
Everyone sign the blues? Everyone got the blues? Missy on the side of the table? Fantastic. On cue.
I didn't sign it yet, but I'll sign it.
All right. You are on that one? Just sign them all. I just run around room to room signing things.
Well, good afternoon. I'm Charlie Perkins. I'm here to talk about this multicast considerations over IEEE 802 wireless media document. It's been updated recently, and some of the reviewer comments were taken into account, but a lot were not. And so I think that after this IETF, within the matter of a short number of days or a couple of weeks, we should be able to provide another revised draft that does resolve comments from the reviewers. And I sent in another version of this presentation that had some discussion about the reviewer comments, but this is not it. I don't know if, is there, because it was only done this afternoon, okay.
So Lenny managed these and got them up, so I wasn't tracking.
Yeah,
So if this is enough, or if you sent a newer deck, I don't know if I got it.
no, I fully understand. I would be surprised if you did upload it.
Okay.
But I was just wondering whether, if there's time today, I could go over the comments later. Or,
Yeah, we'll probably have time.
Okay.
I'm sure.
all right. So what's there? The revision number 3 is mostly sort of a maintenance release because a previous version was going to expire, and there was a number of editorial improvements and typos and basically things that were wrong that got fixed, and then some of the figures in the citations were improved. So this is not too earth-shaking. One section that did get a little bit more work was the section on the recommendations, and that section actually needs a lot more to be fully considered done. So let's see, next slide. Right. So maybe now I'll just describe some of the reviewer comments that were received. And the first one that's easy to remember is there was a question about whether it should be WIFI or WI-FI. And, I'm not real particular on that.
Is there a trademark logo we have to put with that too?
Maybe it's different in IEEE 802 versus Wi-Fi Alliance. I mean, who knows?
Yeah, we might be stepping on toes.
Dorothy, do you know which one that we should use, the Wi-Fi or Wi-Fi? The question is whether to use WIFI or WI-FI.
Oh, well, that's very easy to answer. Just look at the Wi-Fi Alliance website. It's capital WI dash capital FI. First time you use it, it's a trademark. After that, it's just Y dash Fi.
Okay. Well, I'm willing to accept that as an answer. Does
Wow.
anybody?
I'm impressed you have that detail. Thank you.
Actually, I'm not surprised.
Yeah, good.
Okay, so that's easy to do. Then Torles pointed out that there were RSC 3927 and RSC 7772, I think, that were relevant to this document, and I went and looked at them, and I agree that they both are relevant. 3927 is about IPv4 discovery, basically, I think ARP and so on. And so, which I hadn't read that before, but it obviously can be relevant. And then I forgot what the other one is, but I think it's also interesting. There was, let me see now. So Mikhail and Carlos both discussed about whether you should run dual stack, or if you are running dual stack, and after you make connectivity to the internet, should you then disable the other side of the stack so that you're not getting the sort of probably useless multicast traffic. For instance, if you've got a V6 connection, do you really want to run all the V4 multicast service or Discovery or ARP or whatever to try to get hooked in on V4 when you've already got a V6 connection? So to me, it sounds perfectly reasonable if you have a connection that you should disable the other half of your stack and only run either V4 or V6 for that purpose.
Michael Abramson, so were you thinking about putting that into this draft?
Yes, I was thinking about it.
I would not do that.
Would not do
You
that.
don't want to get entangled in that discussion.
Okay, I'm easy. I won't.
I will just don't touch that one. That's gonna bring all kinds of other things. So I actually was coming up here anyway before you said that. When I read this a couple of weeks ago, I think I read it as when I initiated this like a couple of years ago and said we have this problem, like who should do something about it. I read this document as it probably went to the IEEE, and people there said things are the way they are, and that's the way it is. So does that mean that the IETF, after all of this, should say, okay, if we want to use Wi-Fi and run IP over it, we really need to cut down on the multicast? Is that like a conclusion that we should be drawn from this document, or?
Well, so I guess thank you for asking that. I should actually go into some of the context for this. There was a presentation made to Area Working Group, I think at least about 3 years ago. And this was developed in IEEE 802.11 because they noticed that there was problems with multicast, and they wanted to present this material with a pretty good amount of technical backup about what the problem is, and some about the physical conditions that lead to the problem, and also about specifications within 802.11 that have been developed to alleviate some of the problem. Unfortunately, by and large, the additional stuff in 802.11 that was engineered to do this hasn't been deployed.
Right. So I mean, if what people typically buy in the stores that are, I guess, from members of Wi-Fi Alliance, if the product's coming out of this that has the Wi-Fi Alliance logo on it, if they are not going to improve in handling multicast, and that's like the realistic takeaway after these 3 years, then I would say the realistic takeaway is, okay, so the IETF now needs to cut down on the multicast.
Well, shut down's a pretty strong word, but I think that if you're going to design, for instance, in 6LO, they have this document, RSC 6775, and then RSC 6775-update, which is now going to be RSC 8505. And it talks a lot about setting up proxies along what you might think of as a wired backbone. And instead of having all the neighborhoods blasting away multicast all the time to do neighbor discovery, it turns it into sort of a unicast registration protocol. And that's a good thing, because you don't want these wireless devices out there in IoT land to be draining their batteries all the time.
Okay, so I think for most people who come here, you move Ethernet frames over a Wi-Fi link, or you move it over a cable, same difference. I mean, people will design the protocols from that mindset. I think the question here is, if the devices in the field are not going to improve, even like, okay, in 3 years, if it's the same situation regarding multicast as it is today and has been for a long time, then I would say my recommendation is I will go and drive like from the top in the IETF, a drive to, we need to cut down on the multicast. And the decision should
Define
be
shut down on the multicast when we're talking about
for layer 2.
Pardon me?
Layer 2.
Layer 2 shutdown on what in multicast?
Okay, we need to reduce the amount of multicast as much as possible.
Yes, that's exactly right.
Yes, so this is like the conclusion from this document is that the Wi-Fi, so I'm not talking about any other things. I'm talking because those low power, and they get this. This is like a 3GPP device. It has a very special WAN, and it's like, but I'm talking about people specifically. 802.11 are designed, protocols running over 802.11. They run the same code as run on over 802.2. I don't remember which one of it, but it was like wired Ethernet and Wi-Fi is treated the same by the host stack for my PC. So if the IEEE and Wi-Fi ecosystem think that this is not improving the way multicast is being handled by these devices, then I will go and scream at the IAB and everything that, okay, Wi-Fi is eating everything else. This is what people have in their homes and blah, blah. The IETF need to cut down on the multicast. It needs to be a general message to all working groups. Please, do what you can to cut down on the multicast, the layer 2 multicast.
Well,
In Wi-Fi.
Generally, that would, because it's running the same stack. It doesn't matter if it's wired or Wi-Fi. People connect wired and
Right, but if you've
wireless.
got existing deployments that are using it on the wired, and now you're saying shut it down because I can't work it on my wireless, that's a big step. Like, I can't fix it here, so I'm going to break it everywhere.
I'm not saying break it. I'm saying redesign protocols so that they use as little multicast as possible.
Well, I don't think your conclusion follows it, just for this particular reason. If you have a domain where you have some routers that are providing connectivity to the internet, and then below that, you're doing a lot of stuff with wireless, then presumably the routers that are wired together and providing connectivity to the internet, they can direct multicast messages across the wire to each other and no problem down in wireless land. But you don't want to have 1,000 times as many devices in the wireless domain doing the same sort. In fact, they wouldn't be doing, for instance, this RSC 6775 and the update provide for proxy operations, and then they keep binding caches essentially to know where the wireless devices are. And that seems to work pretty well.
Okay, I would, for instance, go to DNSSD, for instance, and say, cut down on that. Cut down on layer 2 multicast that you're doing. And I mean, multicast and broadcast also. I mean, both of these. And yes, sure, if it's only going to run on a wired link, then it's fine. Keep doing it. But for like sending RAs to end systems, to service discovery protocols and so on, all of those should severely minimize their use of multicast. And that should be like a message across the IETF that, look, this is what we need to do.
So, for instance, you might think of, okay, sort of link local multicast is semi-okay because you have to do some kind of discovery operation, but then you don't want to have it propagating across a bushy tree of multicast.
Yeah, so for instance, I mean, having a way where you do have a proxy on the link that everybody discovers by multicast potentially, and then they start speaking unicast to it, and they do service registration there, so they never have to announce it to anyone else because everybody's talking to that guy. That's perfect, fine, because this is one of the mechanisms I'm talking about.
Mm-hmm.
But it's like my device here should basically never send multicast, and something else should never announce itself using multicast. I mean, it should try not to.
Right. I think we're basically agreeing here.
So, I mean, I just, in my discussion initially, I just wanted to make sure, who will solve this problem? And I take it here that the IEEE and the Wi-Fi Alliance has said, not us.
Well, that's not true.
Okay.
They have provided tools that help ameliorate the problems. And there's a lot of considerations about, duty cycle and sleeping and all this kind of stuff that are supposed to be spelled out in this document. Enough detail for us to understand.
I know. I could theoretically buy a Bentley. It's just that most people don't. So saying the Bentley might have something, that doesn't solve people's transportation problems. So the thing is, what will be in 90% plus of people's devices? This is what I'm asking, but this is like an ecosystem. It's not like, oh, that optional thing you might get over there, that nobody has, that's irrelevant.
But look at it the other way. Supposing we publish a document that explains how to do some
Right.
engineering to improve the problem, and then some enterprising manufacturer realizes, hey, we got a document out there. Let's build to that, and we can sell the access points that live by that.
No,
No,
Then
you
this
don't
is.
think so?
I mean,
Well, but,
people
can I
gonna,
just, both these are, we're arguing economics on both sides here, and that's not our intent. Our intent is some technical direction. So what we do with the technical direction is a good conversation piece, but let's get some other people with the mic and see what their input is.
Okay.
Yeah, I agree mostly with what Greg just said, is that our intent is for providing technical direction. So the reason that we created this draft is that we were just getting a lot of questions from people about what's the deal with multicast and Wi-Fi. And so we said, okay, let's create the document
What's the deal
to
with
describe the
multicast?
state of the union with regards to multicast and Wi-Fi, identify the limitations, add some recommendations, and that fits right within the charter of Mboned without going too much further than that. That's our goal.
Then go surfing.
And go surfing. So if you wanted to go further than that, then maybe we need to.
Okay, so I'm not criticizing the authors of this draft in any way, shape,
No,
or
no, I
form.
think
but it's like if it's, so when I've been talking to people about this, it says next steps, and for me this is like, okay, this document is done, soonish,
Yeah.
and then what? What do we do then? This is what I want to start that discussion. If that's too early, I can wait. But this is like, I want to have that discussion at some point in time.
Okay.
Thank you.
And Stig, well, sort of going back to that, at least I'm worried about IPv6 neighbor discovery, right? And do you expect equipment to do all kinds of special tricks just to make neighbor discovery work in particular? Maybe you can do that similar to ARP optimizations for v4. But it means that you can't really easily maybe extend neighbor discovery because they will just implement whatever, I don't know, hacks that are not really in the design.
They do this for v4 ARP already and have been for a long time.
Right, so I guess they will do similar things for v6 then, for maybe.
So it's not the purpose of this draft to propose new technical solutions for
Yeah,
things.
yeah.
If there are technical solutions or, let's say, operational approaches, fair game, we can mention that.
Okay, let me explicitly say I fully support this draft and all. I don't oppose to anything that is in it. I'm asking, what do we do after this? And I might be asking this too early.
Okay.
Yeah, I agree with that. I like this document and
Thank
I'm
you.
also worried about this.
Well, that was a great discussion.
Yeah, excellent. So this is a good point. Do you feel this is ready? I mean, you're asking right now. Who's read the draft? All right, excellent. Who's got a census like ready for last call? Kind of cooked. Okay, so we can bring that up on the list, and let's get this discussion going on the list as well. I mean, that's, as an ops group, it's our intent to provide direction, but not necessarily articulate a solution.
I have, okay, please go ahead.
Is that after responding to the remaining reviewer comments, like you said?
So I
Before the
want
last
to
call.
mention that Jake made a lot of great comments, and we, I think all of them, with one exception, just belong to be resolved in the draft. But since you're here, I wanted to mention that I didn't think that AMT really fits in the draft because it's not, doesn't run over the wireless. So
It is a unicast way to address multicast. It's as a mitigation in the same sense as the multicast unicast and the DMTS.
And I'd say
DMS. That's right.
but from an
That's
ops working group, I think that is a fair assumption. I mean, I'm not going to stand hard on it, but to come, because it's almost like we're given like a blind response, right? It's like, oh wait, this doesn't work, so break it or get rid of it. It's like, no, wait a minute, it doesn't work, so here's how you make it work, right? And even if it's not at the wireless side or the layer 2 side, but if you as someone with multicast content, multicast service provider of some kind, or deployed across a multicast network, knowing how to get it across those segments is something also we should be providing direction.
That's why I suggested it, and that was the intent there as part of the solution.
if we make it as a recommendation to say, solve part of the problem, and then it'll be reviewed as part of the document progress. Okay.
Yeah, and it doesn't have to come up as a recommendation either. I mean, like we've done in the past, we've given guidelines, drafts, and transport. There's one like, what do you do with multicast and UDP?
Sorry, yeah, I didn't mean to say promote it as a recommendation.
Sure.
I meant put it in the list of
Absolutely.
ways to get unicast
Yep.
for the multicast stuff. Yeah.
Because it's got an RFC, so you start pointing to standards, it becomes a roadmap effectively. If people look for solutions.
Okay.
And I don't remember if it's in this draft, but so having multicast used as, finding something, announcing something periodically, that kind of works. But running like a multicast IPTV stream over Wi-Fi, that is just a complete no-go, doesn't work at all because you have like 10-20% packet loss. So it's a complete no-go. So these are like almost two different problems because, so yes, AMT for that kind of high bandwidth, traffic, that's just a very obvious solution because that doesn't work at all. I don't know.
What doesn't work about it? You say
No.
packet
So
losses?
if you run multicast on Wi-Fi, you have like 10% packet loss in congested environments,
And
there are no retry. And if you're running an IPTV stream, typically it doesn't work over 10% packet loss.
well, if you're running clear UDP without any repair symbols, or you've got no layered codec, absolutely. If you're going to see this just raw data packets over UDP, loss is a problem.
Yes.
But the reality is, we're network guys, and we keep our heads down thinking network. But it's just not. It becomes an application problem now. It's UDP. You're going to lose packets, and if this content is that important to you and your customers, you need to provide a protection layer that accommodates for what expected
Right.
losses may come.
Okay. So the expectation on a wire, or when people typically do this, is 10 to the minus 12 bit error rate.
DSL. That's a wire.
Yeah, sure.
No,
It
no,
has
lo-
that. It
Loss
has,
is horrible there. But what they do with the layer 2 is they add repair symbols to
Okay.
get where your
no,
distance.
okay.
So you get the
No.
same thing.
Okay. So in Wi-Fi, there is no repair.
Oh, yeah.
There is no retransmit.
Right.
So for the application, the packets are just lost, and this is like magnitudes worse than any other media it
You
might
just
be running.
restated yourself again. That's not a problem. The point is, if that content's important to you and your customers, you have to solve an application layer. You have to come with an application layer solution that gets you there. And there's
fine.
stuff's out there, right? So my concern is saying, this works, so it's all broken. It's like, no, this works, and now this is broken, so now it's your problem to fix it a different way. We can't fix it here. It's UDP. It's just flat out UDP. Whether multicast, unicast, doesn't matter. It's UDP over, well, no, I take it back. You're wrong. I'm wrong. UDP over multicast and Wi-Fi. There's no retransmission for that MAC.
Correct.
So there's the gap. But
Yeah.
I don't expect that between two router hops either.
But it's like, if you run it on a wire, your loss rate is going to be fractions of a percent, probably. And here it's going to be tens of percent.
So run a better protection.
Yeah, well,
Yeah.
but okay. The point is, in Wi-Fi, there is no protection.
No, do it at the application. I'm not, if
Okay.
Wi-Fi is going to screw
Okay,
you.
but sending more multicast packet is not going to help.
Okay,
You know, but
now
if-
you're articulating a solution that I didn't propose. I said put it in the application. I didn't.
Sure.
We're going to argue what those application solutions can
Okay.
be. Let's take it offline.
So
And there are retransmission schemes at layer 2 for multicast, but
Well,
we don't have
they're
to
just
talk
not
about that right
they're
now.
just not
Yeah.
deployed.
Okay, it's a matter of choices.
okay, so some reviewers, we'll take it last call. Last call doesn't mean it's gonna be done. It just pushes everyone through to make those comments so we can get there to being done.
Might be
Uh,
a good idea to wait until
yeah.
I resolve all the.
Or you're gonna resubmit it or
I'm
rev?
going to resubmit, let's say within 2 weeks. or so.
Okay, so when the next rev comes out, we'll follow it up then. Perfect, thank you.
All right, thank you.
And next is Mr. McBride. Are you presenting? Mr. McBride, table for one.
That guy's so tall.
Yeah, I know. We see him jump over. This one's kept bringing it.
It's just crazy. It's just funny.
Right.
All right, so this is a document that has had a major rewrite in the last 6 months prior to the previous IETF. We did not update it for this IETF, but we thought we'd just give it quick overview so that hopefully other people either want to be a co-author or can just review it and contribute to it, because we're pretty close, we think, to getting this thing done. The reason that we did it is, I think, somewhat similar to the Wi-Fi multicast thing, is that in the charter of Mboned is that there is a need for regular reports on the current state of deployment of multicast and create these practice and experience documents. And so that's what we've done for this draft for multicast in a data center. Next slide. There's only a couple slides. Yeah, boop. All right, that works. So some of you may remember ARMD. I believe it was address resolution for massive number of devices, if I remember right. So it was closed some time ago, but this discussion came up there. Many people saying that multicast in data center just doesn't work. It's the no-go, too many problems with hardware and scalability. And others said, you know what, that's completely wrong. Multicast in the data center is vital and we use it. And so there was a lot of confusion about that. So we said, you know, let's create a draft that just talks about that. We'll do it in Mboned. People have questions, then they can turn to that. So we do have a new rev. Again, previous to the previous IETF, Femi with Arista, I think. I can't remember now. He's a co-author. He did a major rewrite, and he did a great job, including a lot of things. We talk about the problems with multicast in the data center. We talk about PIM and how it's, you know, it's good that it's mature. And the problem, however, is that in data centers, the scalability and the significant increase of one-to-many traffic that we envision, PIM will not be something that would be successful in a data center. So there's other alternatives, even though PIM is used for a variety of applications, such as market data, which is probably one of the most successful areas for multicast. We highlight that. We talk about IPTV as well, and the scalability of 4K and HK, and how that will need to scale and is trying to scale within the data center. We talk about some new technologies like beer briefly, and we talk about BGP VPN as some good options for use in the data center, and a few other observations and highlighting a few other use cases. So we think it's a useful document. It's been adopted, and again, we feel it's probably within the next IETF or so, ready for working group last call. The plea, again, is from the working group to just review it, make some comments. If you want to do a fair amount of writing, then please join us as an author. And any questions?
Wow, animated crowd.
Wi-Fi was much more animated.
I think the problem is you gave this presentation over Wi-Fi and have loss. All right.
Okay, thank you.
So you read some issues, so we'll track it there before we do the last call.
That's right. We're not quite ready there yet, but
ping me.
I will.
Thanks. And we got one more between you and dinner. Ingest platform. This is a fun one. You're all posers. This guy's actually doing stuff.
Hi, I'm Jake. This was, did you see my writing stack? It's this tough.
Absolutely. You saw no other stuff.
So, all right. I have a draft, and I'm going to be asking for adoption. And the draft is implemented at the hackathon. I did and what it's about is DNS lookup to find the right AMT relay.
Was
okay.
this resurrected from AT&T, or you just merged their ideas?
Well, I was inspired by their use of DNS.
Are you still working with them still?
No, I haven't heard anything from them except yeah, go ahead.
Okay.
So with their blessing, I put them in the acknowledgments. I appreciate their work. I think it was neat. I did it kind of a little bit of different way. It's a R type, a new R type I'm proposing. Okay, so anyway, this is what I ran. I have a few relays up, on the internet with with multicast traffic behind them. Actually, some of them aren't mine. There's the Internet 2 is just forwarding actual traffic, some coming from the NSF. And Lenny put up a couple of public relays. You can just reach them. These machines I brought to the hackathon, and I put free range routing on it, and I just hooked up a PIM and OSPF and ran it like this. Next slide.
Yeah, it's not working.
All right. So the idea is, just pull in AMT and forward native multicast through my little multicast enabled network, right? This is like my little pretend ISP. Okay, next slide. So the signaling is where the draft is focused. So the way it works is the client I was running a Mac with Mojave and had VLC on it, and it just did a join. And it was just using the UDP, the MPEG TS encoded video, and that just works on its own with the SSM join. It goes through PIM between the access and border router and into the ingest router, and the ingest router, the new agent I wrote while I was here was do my new DNS query. So it's a reverse lookup on the it's a lookup on the reverse IP of the source address, right? So you've got the source address, and you put in a new record for that source's address, and the source knows that here are relays that can receive traffic from me. Okay, and so that's coming through the zone that the source controls, and the spec has if it's a pointer, then you should do a lookup on that instead and find it there, and it gives you an answer that says here's the relay that you should use to contact, and so I do the DNS query. I'm running my own DNS server. It's I was amazed all the tools like handle unknown RR types. That's been around for 15 years. I never knew. And so then it just launches the new gateway to talk to the given relay that corresponds to the source, and then opens that tunnel, starts sending stuff through. So the upshot is that we have sources that are across a non-multicast network. They have a relay that the sources know about. You can just do your join in the router that you control, and the clients don't know anything about the gateway, about the relays or the gateways. They're just doing a multicast native join. The multicast network that the clients are living inside can propagate that join and take care of it on the on a side that's not right next to the client, but further up in the network where it can do the fan out. Right. Okay, next. So this is the way it's supposed to work, right? You have PIM come in, and you have the nice triggers that FR routing provides, and based on what it does, it's got the little the join, and it's coming in through you just say that you've got the default route for your RPF lookup in the thing where you're going to launch your gateways, and and my co-author on the integrity, we're working on an asymmetric integrity also, so that's a separate thing. So he was working on that. It's supposed to go through there. We want that to be part of the platform eventually. It's not there yet, but this is what it's supposed to look like. Yeah, next slide.
I got a question for you.
Question, yeah.
Is Greg is a contributor from Cisco. When router gets the new SG source, isn't there a decision before it goes right to the relay? I mean, couldn't this be an operation where if it has an RPF neighbor to the source, it just sends a PIM join? If it has no RPF neighbor to the source, then we have to look for another way to get to the source.
Oh, yeah. So that's you do that through the IPM route, right? So it wouldn't come to the ingest router if the border router had an RPF to the source, because the border router also is configured with IPM route toward the ingest router. So the border router is configured to know.
Oh, interesting. Right. Your gateway is not your border. So
Yeah.
how did that join get over to the gateway?
Yeah. So there's also an IPM route on the border
Okay.
saying go to the ingest, because he knows.
Pushes
Yeah.
everything down there, and then it knows immediately when I get it, I send it. Okay.
Yeah.
Excellent.
So RPF's going to work. The same way as all, yeah, if you've got RPFs you know about, if they're more specific than your default, it should work fine.
So you can run that as like a gateway appliance effectively if you.
Yeah,
point it
that's
that
the
way.
idea. So, and yeah, you should be able to also do like load balancing. You can split up your resource space and have different ingest routers. That all should work okay if you want to run it that way. Again, this is in theory still. So in practice, it's a hackathon project. So the biggest problem actually is, the two biggest problems. No IPv6 is bad. Okay. FR routing didn't have it in PIMD. I'm going to try the troglodyte one. I think that might be there. I'm not sure. And then the other biggest problem was I can't actually do the IP mroute. So you had to add the sources so that the RPF would work.
Okay, right.
So that's like just a bug that they haven't solved yet. It'll be there eventually. I think if you did it with a more mature routing platform, it probably would be fine. But in practice, I had to add these sources so that I could get the RPF to actually go. But and then I'm not using the nice hooks because again, it wouldn't do the RPF through the ingest router just because there wasn't a PIM neighbor. It's like not very so okay, it's a little bit jankier than I thought. And what I ended up doing is essentially I'm just watching the output from TCP dump. But the information is there, and that's what I'm using to perform the trigger. So I get that join in, and because of that, I launch my relay. I launch my gateway with the target relay IP, and I issue a join into it so that the join goes where it needs to go. Next slide. Right, so I got the running code, check, and now I'm looking for the ref consensus. You can try it. There's the I put all the configs and the code on my GitHub. You can look at it. And this is what it looks like. The stream that's running on I2 is actually kind of fun to watch. That's the knowledge network, and it's very cute. It's all sciencey stuff. It's about 12 megabits. So there's a section. The Torless is onto this. Torless was onto this. I was talking to him earlier, and there's a question about like if you have, for example, the Wi-Fi router issue, and you've got like in a home or an office, you have a local hop which is not multicast, and then you don't want like the lower layer to go all the way to the sources relay. You want it to go just to the local relay, so that when you have your multicast enabled ISP, you're still going to use them for the forwarding. Like the real point is to get across that access network where you need to share the traffic, right? So I tried to explain that in the draft. I think there's still some work to do. I'm going to talk to a couple of people about DNS service discovery and see sort of what's the right way to do this. I have a sort of is home.arpa the right answer question in there, which I don't really know the answer to yet. Right. But there's also DNSSD, which might be, both, but my first question really is, and the security section, I have just a few stubs of the most obvious problems I could think of. I think it needs more expanding. I think solving these two issues, I would hope that it's actually a worthwhile thing that Mboned, wants to adopt. So, so my question is like, do you agree? Should I move forward with this? And is this going to find a home here?
Who's read the draft? That's going to be tough. All right, who thinks this should be adopted in the group? Yeah. All right. So it's impressive. One reader and 2 yeses.
Very nice. I think that's against the rules, but yeah.
And Michael Irvin, so I don't know about adoption, but it looks interesting, and I can see this being
Excellent.
useful. And I think it's good that I hadn't thought about the whole DNSSD, because I mean, if you're running this on the home gateway, you want to be able to discover it perhaps using DNSSD, so that makes perfect sense. But then again, would it actually be using I mean, then it wouldn't be using reverse lookup potentially. I don't know, but this service should be discoverable using DNSSD, even though it's using DNS for something else.
Yeah. So, right. I think there's maybe 2 layers on that. And that's the recommendation I put in, is that the source should put in the thing that the gateway in the home should do. But maybe there's a different way to do that, where the gateway should have a default that comes before following the service discovery. So I'm not sure what the ideal answer is, and that's something to work out. I'm not going to bother if nobody cares, but if this seems worthwhile, then I would like to, do it here.
This is Greg again. Didn't AT&T provide a layered like architecture where if you had a local relay, you can announce that first, and then once it left your domain, it would look for external relays?
Yeah, I couldn't follow it. I don't know. It's sort of, yeah, but they were doing something with more A's involved, and it was a little different. So the RR type, what I've got in here is like a new RR type that means this is the relay that the source knows about. And I think that you can chain that if you have a more local DNS, right? Except maybe if you have DNSSEC, then maybe not, right? So there are complications on how to do that, but yeah.
Michael Abramson again. Do we have something today that does the whole? Okay, I want to run AMT within my home to my residential gateway, and I want to discover either way. And I know there are proprietary solutions for this, but do we have something in the IETF to do this, like that is standardized? I don't know.
What do you mean, like how to? You said using AMT, so that is a standard. You mean how to use
right?
AMT in
But
this way,
discovering it, and what do the clients do to discover it
So-
and get that running and so on?
Yeah, so AMT has a well-known IP address, an Anycast IP. You could run that in the home.
Okay, but if I don't want to use an Anycast address,
Well, the AMT draft leaves other discovery options open,
okay,
or the AMT standard, I should say.
right? But that could be This
Yes,
could be
yes.
adding
That's the
this.
intent.
Yeah.
Yeah.
And then would you envision maybe a BCP that shows putting the pieces together?
Yes.
That would make
be good.
sense.
That would make sense, yeah.
All right.
Did I have another one? I think
So
it was
let
just
the
asking.
notes show that there were twice as many yeses as there were readers. That's important.
Okay.
Oh, yeah.
Yeah. Oh, and if anybody wants to see it, I still have the stuff in the code lounge. You can come over, take a look at PCAPs,
Free
see
beer.
how it goes. There's not free beer. There's free beer for me if you bring me free beer. That would be great. I would definitely come for that. And if anybody's interested in like telling me how to do this with their vendors, if they're vendors that want this to work on their router API, then I would love to do that. Yeah. So let me know if you want me to play with that. And yeah, thank you.
Beautiful. Thank you much. That's our last presentation of the afternoon. We have some comments.
No, I have some other business. I just
go for
realized.
it. Yeah.
Okay, Michael Abrams again. So between the past two IETFs, I actually took the hackathon code. There was some work on IPv4 to IPv6 multicast and MLD and IGMP work, like for hackathon 2-3 years. No, 20 it was even
Yeah, it's
longer.
a while ago.
2012. I actually took that code and made it work with SSM. So I'm running IPv6 in my core to the home gateway. It turns it into IPv4 multicast because I had a set-top box where they just would not do IPv6.
Oh.
So it could do an IGMP v3 SSM join, and it would then turn it to an MLD v2 SSM join. Packets started flowing over v6, and we were running this to our AFTR. So this was IPv4 in IPv6 encapsulation of the multicast packet. So the thing running on the home gateway would just decap. It would just decap it and throw it out.
Yeah.
So to the home gateway, this looked like it was v4 all the way. It couldn't tell any difference. So this is how we're doing IPv4, unicast, normal internet to the home. We have one tunnel for that. So this basically set up a second tunnel where not even a tunnel. It would be multicast SSM, through the core, But so the AFTR ingested IPv4 packets and then just slapped it into a v6 packet. So I had a one-to-one mapping. And we didn't even have to change anything in the AFTR because it just has very stupid one-to-one mapping rules. So we didn't even change anything on the
But
AFTR.
you didn't do that here at the hackathon? You did this on your own?
No, this was we did this on our own. Yeah.
So you show up at the hackathon and just like not do anything and just throw some code down.
Yeah, right. So it just struck me that yeah, should that do anything? I mean, I didn't invent anything really. I just put
So
some
what was that?
standardized stuff together, and it worked.
That worked for Wozniak really well too.
Huh?
That worked for Wozniak really well too.
Yeah. Okay.
Yeah.
Fine. But
Seriously.
yeah.
Pieces
Yeah.
are
So,
there.
so
Put them
like I
together,
didn't
right.
invent anything. I just glued stuff together, and
That's what engineers are all about.
yeah, I know. So the question is, do people come here and say, like, is this something we could I should try to document? I don't know.
Is it? Yeah, absolutely. It'd be interesting. I don't know where that work has gone. Most of those drafts kind of died over time because I'm just from memory here. I'll try to be as careful as I can. There was a boil the ocean kind of approach that was going on there.
Yeah.
Let's convert the in and out of every possible combination
Yeah.
there. And we're like, okay, let's find out what our migration strategy is and trying to build the architecture around and
Yeah.
those pieces that are gapped. And
Because this was some kind of multicast tunnel. It had to do with encapsulation. It had, we actually turned out to, it actually ran PIM as well from the AFTR to the router. So the AFTR was speaking PIM to something, but we just stopped doing that. We just said, I just, made an MLD static join, just sent the packets at the AFTR, and it just slapped it into an IPv6 packet and then sent it out.
so was this based on expired drafts? Or?
I need to look
Okay,
at that again.
But if it is, or whatever drafts, or if it's not,
Yeah.
and you
So,
want this
basically,
becomes-
okay, what I'll do is I'll just write an email to the list and say
Beautiful.
I did this,
right,
and let's see if someone jumps on it.
perfect. Thank you. That's good info. Good work. Anyone else? Anything else? Who's got the free beer? It's not happening. No free beer. Everyone sign the blues? And all right. I think we are a wrap. I can tell. Thanks, everybody. Have a good, safe week here in Thailand. And we have a successful Chromebook event completed. That's exciting.
Good to see you guys all in this.